G'day guys, Alan here. Welcome to my workshop. So today I want to get started on something I've been thinking about doing for a while, which is to make an ER40 collet chuck for my milling machine. Now I already have several of these, but the ones that I've got are quite long in the body here. This one not so much, this one obviously a heap. And it's been on my mind for a while to try to find a way to make one with a much lower height. The objective being, of course, that I would then have more usable height underneath whatever's in the collet chuck. So to that end, and using my newly acquired CAD skills, I've drawn up what it might look like. You probably can't see that terribly well, but as it happens, a friend with the 3D printer, when we were swapping notes, decided he'd print one out for me. There it is. And hopefully you can see that that's usefully, go back a bit further, that you can see that that's usefully shorter than these, but particularly in this dimension here from here down. This 3D print, even though it was a draft, worked out quite well actually. So actually all of the threads, surprisingly, are operable. And I've had that screwed on so you could see a direct comparison, but I think you'll also be able to see that the major height saving comes from doing away with this blank space here. There's nothing you can do above this line, of course. This is 10mm standard, but I think 8mm would be enough, which is what I'm going with. But anyway, as you can see, the end result should be something which is usefully lower. Right, so what am I going to make it from? It needs a decent sort of piece of material, of course, and I was fortunate the other day to come across some of this stuff. And how well you can see that, hopefully that's just come into the picture. This is a hydraulic piston, 75 OD, chrome plated, and it's made out of 1040 I believe. And I was fortunate indeed, because I picked up 3 of these for $10, and I don't know what the new replacement cost would be, but at $10 for 3, that's barely scrap price, so very happy. So anyway, I haven't tried to turn this 1040 stuff before, so that'll be an adventure in itself. But I'm hoping to be able to use this end, basically, start at this end. But there's several challenges here. I don't know whether you could see that. Start at this end. Anyway, a key challenge for me is that this guy has got a taper on this side and a taper bore. So I've got to give quite a bit of thought to how I'm going to hold this thing so I can do both tapers. So it should be fun. Better get straight into it. Okay, so my first hurdle, I've decided I want to use the fixed steady to support that long bar until I get it cut down to size. And it's the first time I've tried to use it. And the clamping hardware is pretty ordinary. It's got a big cast iron lump that comes underneath, and then just this plain bolt to, and I didn't like that at all. And the reason I don't like it, is that to use it, well, it flops about anyway. But the main problem is that you need 2 spanners, one to hold the head of the bolt and the other, don't like it. So I've made this up. I made up a T-nut. A bit of a close-up here of that. I didn't take any film of making the T-nut. It's pretty standard sort of operation. Anyway, and this is a bit of 16mm threaded rod, and it's just a jam nut and a washer there, just so it can float about in generally the right position. So now fixing this into place is I don't have to worry about dropping the bolt down the hole. Fixing this in position is quite easy. I made up a decent putty washer too. I was actually surprised that given the quality of the machine they had such an ordinary arrangement for this. But anyway, they did, but it's fixed. Right, so that should work out alright. Let's get on with positioning the piece of metal. Alright. Right, so one end of this guy has got a small parallel stub on the end, and the other end here has got a nice centre in it. So we'll make sure these are a bit on the low side. So when I wind this in, it lifts it up. Right. And I can give a good push on the end here because the way this thing is formed is like a little shoulder which will press on the face of the chuck jaws, the ends of the chuck jaws. Ends of the chuck. Anyway. Right, so make sure that's good and tight. Now I don't know where I want this yet. Keep it out of the way. And bring it back into play. So I've got to strip this chrome off for some distance here. The plan anyway is to strip this back and then I can cut the piece off with a bandsaw. I don't want to try and cut this chrome plating with the bandsaw. And the reason I've got the centre here, when I take this out and cut my piece off, I can put it back, face the end and put a new centre in to make sure that the next setup involving this thing is a bit easy. Well, that's the plan anyway. Alright, haven't tried to machine this sort of stuff before, so it's a bit of trial and error. I just did a quick try there. I'd like to be machining at 0.3 feed to make sure I get proper chip breaking. And I've only got it set for a 0.5 millimetre depth of cut, so let's just see how that works out. Because the other problem is that the drive grip is on a small diameter up the other end. Anyway, we'll see what happens. It's getting bloody hot. I'm not sure I'm going deep enough there. I might try going in instead of 0.5, let's try 0.75. Well, hopefully that stripped the chrome off anyway. Alright, it's pretty tough stuff this. So when I made the T-nut, I had to drill a 14mm hole, and twist drills are supposed to look like this, but my 14mm drill was absolutely destroyed. The material grabbed hold of the end of the drill, unwound it, and then absolutely obliterated the end of the drill. I've never seen a drill failure like it. Yeah, let's give that a try. So I battled on with a number of cuts, trying out different combinations of feed rate, speed and depth of cut, and eventually got through the really hard layer. So we'll try a 1mm depth of cut and see how that goes. Oh, pretty happy with that. Now, this must have been induction hardened. It took me a while to get underneath all of that, but it's cutting all right now. So we're aiming for 63. And we've got 65.13. Right, aiming for 64 diameter with this cut, and I've cut the feed back to 0.1. Let's see how that goes. That feels pretty good like that. Okay, we're going to call that 64.01. So this next one is going to be the last cut to get to 63. I'm not really that fussed about the surface finish here because this diameter here will become that diameter. So I'm not so fussed about the surface finish. It's pretty good anyway. And I'm not changing inserts at this late stage because one more cut should get me on size. Right, set to 63. All right. Well, so hopefully we've got 63. What do we get? I don't know whether you can see that, but that looks to me like spot on. A little bit of luck there, I think, to be that close. So, having got the piece of stock down to the sort of maximum diameter of the NT40 taper, and I started roughing the shall we call it the tail out to get to the dimension. Now, because there was a lot of material to come off, I decided that rather than trying to do it all with the taper turning process, which was going to be achieved by moving the top slide backwards and forwards, so without power feed, I decided to rough the taper out with a series of steps, so at 20mm marks, to go down from 45 to 40 to 35 to 30 diameter. It was a good plan, but there were several issues. As you can see, I had a lot of trouble with the insert was cutting sort of nicely, but producing these really horrible stringy like long razor blades, and it was I didn't like it at all. It was dangerous. So I had a number of goes at changing speeds and feeds to try to deal with that. And so what I'm doing in this one is a 2mm depth of cut on the diameter, or I should say 1mm depth of cut, 2mm off the diameter. And here I'm just making a big mistake because that's supposed to be the third step 20 wide, and so I should have stopped at the 60 mark. So I think that's going to have consequences. Anyway, I'll press on, and at the worst it can be a practice piece, I suppose. But also I'd started to make some headway with getting the chips to break at this point, and it was a much safer and more pleasant turning experience. So I finished the steps out anyway, and got down to the minor diameter, well, close to it. I'm sitting on 26 millimeters here, should be down at 25.3, but that's basically finished the roughing out process. Right, so I'm getting set up now to actually machine the taper, and this is ER40, and the ER40 taper is defined as 3.5 inches in 12 inches, or otherwise known as 7 to 24. Anyway, what it amounts to is 8.297 degrees is the included angle that I've got to set the top slide to, because I'm using the top slide to do the taper. And so I'm using a thing here called a lathe compound sine bar from Tangent Engineering. It's a simple bit of kit, 3 big magnets and 2 pins. In this case they're set exactly 5 inches apart. So with this pin on one side of the top slide and an appropriate shim stack on this side, we can set the angle exactly to as exactly as it's possible to get in this sort of setup, to the 8.297 degrees. So the shim stack turns out to be 18.326 millimeters, and that's what I've got with my gauge blocks here. This measuring method has its own limitations. It's pretty accurate, obviously, but you'll see as I wind backwards and forwards, it's not completely consistent. You get little bits of movement in the needle, but averaged out, this is pretty much the best I can get, and I think it's going to be fine for this. So I'm going to call that done and get started with cutting the taper. Well, I've never tried turning a taper before, but that's going so easily I wouldn't have bothered with the steps, so I won't do that next time. But it remains to be seen whether I ruined it by getting my step spacing wrong. We'll find out soon enough, I guess. I've been taking millimetre off the diameter with those, or 0.5 millimetre depth of cut. Now I've got to make sure I finish up in the right place here. I'm not actually sure the right way to do that. Sneak up on it, I think. Okay, well, I'm set up now to put this groove in the tail of the thing, and I'll be using this button insert tool. This is a new bit of kit for me, I haven't used it before, so I don't know how we're going to go, but that's a 5mm diameter button. I'm going to try and plunge in 2, and we'll see how that goes. think I must be a bit high. And that seems to be going right, but I might be going a bit fast, I think. So we'll call that it. Well, that's looking all right. It looks like I got away with my misstep there. So I've got a little bit further to go. So I think my next cut will be the last. Well, that turned out pretty well. I hope it's the right size. It's certainly a beautiful finish. All right. Right, so I've chopped my piece off the end of the rod. I've got it mounted in the forejaw, and got a pretty good centering, at least at that end. Check and see what's going on at this end. I think that's it. I'm going to fool around with this anymore. I'm going to call it good enough. So next operation is to drill and tap for the 16mm drawbar. Right. Just want to get a good chamfer on the hole now before I start the threading. Should do that nicely. Right, ready for some tapping action. hard work. I think that'll do it. Put a bit of heat into it. Alright, so I think that's finished everything on this end. Okay, so I've taken the piece out of the forge jaw, and I want to do a test fit on the taper, this NT40 taper, before I go any further with the piece. So I've used this handy dandy little gadget to clean the socket, and I'm going to put a little bit of bearing blue on the taper, and we'll see what that tells us. So anyway, we'll put a little dab here, and really what I want to do is put a smear just like that. So now I'm going to put it in the socket and give it about a half turn, and we'll see what the pattern looks like on here. Got a drawbar in there at the moment as well. That's going to be a bit of a nuisance to me, so I'll just pull him up out the way. Alright, here we go. Yeah, that seems to have gone pretty well. I'll be happy with that. So I'll put it in. I'll just wipe that bearing. Try and wipe this bearing blue out of here. And I'll put it in. I'll just snug that up. And then when we go to loosen it, hopefully it'll be lightly stuck on the taper. And indeed it is, so so I'll have to tap it to free that. Well, that seems pretty satisfactory to me. Okay, so I've decided that the best way to hold this for the next machining operation, the ER40 collet end of it, is in fact to make an NT40 socket, basically an imitation of the milling machine quill. So to do that I need a piece of material. So I hacked this bloke off the rod, and in the process discovered something a bit interesting. The untouched diameter of this material is 76.2, and after I did what I thought I'd taken the chrome and the hard layer off, it's down to 75. So I've already taken 1.2 off the diameter, or 0.6 depth of cut, but you can see, I think pretty easily, well I'm hoping it shows up on the camera, this hard layer here. So even after taking 0.6 off, I've still got another 1.5 of the induction hardening, which I believe that's what it is. So basically it was nearly 2 millimeters, a 2 millimeter thick skin of really hard stuff, and that caused me a bit of grief until I worked that out and changed the way I approached it. Anyway, so for this bit, the next thing is to put it back in the lathe and bore it out and do an NT40 style tapered socket for this guy. And I'll set it up so that this piece, I think if I can turn it around a bit, the socket's going to be just a bit longer than this, so I'll be able to put a bolt and like a draw bolt, a short draw bolt to hold it in. Anyway, that's the next thing to do. make an NT40 socket. Right, I've got my piece of material for the NT40 socket in the 4-jaw and dialed in. I think I'm probably within 0.005, something like that. I mean, obviously for a chuck, the better, more accurate you can make it, the better. But I think I'm within the limits of accuracy of the dial gauge. Anyway, it's going to be what it's going to be. I have to say though, I'm not really a fan of this chuck. Even though the lathe itself is a pretty good quality machine, it's pretty ordinary. I think 4-jaw chucks are the poor cousins when it comes to speccing these sorts of machines, because realistically, I suppose, they don't have to be made that accurately to get a good, to be able to get a good result. But it just doesn't feel very nice to use. It's not smooth like my Bison 3-jaw. But then again, the Bison 3-jaw was a $1,000 chuck or something like that. It was pretty expensive, and I can imagine this thing's more like $200. Anyway, let's start machining. Alright, let's see how this drilling goes. I'm using a 24mm drill with no pilot hole. We'll see how that goes. Seems to be going all right. Takes quite a bit of effort to push the drill in, but it seems to be cutting all right. I think the tailstock's slipping against the load. Yeah, I think I might put a pilot hole in. It's just taking a lot of effort. The drill's cutting pretty nicely though. I think this guy's 18. I think we'll try 250, see how that goes. Alright, all the way through. It's quite a long drill, 100mm. Alright, time to send a bigger guy back now. Alright. Got a 24mm hole all the way through. Okay, set up now to bore the taper in the socket. I didn't mention them before, but this plate comes with these nylon or plastic jacking screws, and they're really useful to get an initial setup with the plate, because they are quite strong, these magnets. Anyway, so I've reused the same shim stack and I've got it all dialed in, I hope. Don't know whether that will show up very well on the camera, but it doesn't matter. Trust me, that's pretty good. Okay, so I'll get started with some boring action. I've just got to get this angled correctly. So I'm starting off with an opening that's 25.5, and I have to finish up with an opening that's 44.45. Let's get started. So I'll check the finish and slow it down a notch. The finish isn't too bad. I've got a used corner in play at the moment, so when I get close to the end I'll put a new corner on. Anyway, that seems to be going alright. So we're out to 32mm now, so maybe about halfway there, something like that. Okay, so let's finish the boring. The finish isn't superb, but I think it's good enough. This is just one of the ones I bought, and that fits in there perfectly. The one that I've made doesn't fit quite so well, and the reason for that, the hole that I drilled through, the 25.5mm hole, wandered off course at the tail end, and this is 25.3 and the hole's 25.5, so there's not a lot of room. The reason this guy fits is that this tail end on the manufactured one is a bit smaller. It's about 20. Yeah, about 20 I think. Anyway, so that's why that one goes straight in. So that's all fine. I could run the boring bar through and true the hole up at the end. I think that's probably what I'll do, or alternately turn this down slightly, one or the other. Anyway, this taper boring was a success as far as I'm concerned. I've just got to do a chamfer, and I think also I might cut this ring of this skin of induction hardened material off back a little bit, because I've got to cut some slots here for drive dogs, and I don't want to run my milling cutter through that stuff. So I thought I'd test my socket against known, or at least presumed, good NT40 taper and see how that works out. Well, I'd be pretty happy with that. That's I don't reckon that could be any better. So I think we'll call that socket good at least, even if my other thing is a bit sus. Anyway, I'm very happy with that. So let's see what my item picks up from the blue that's now in the socket. I don't know how well you can see that, but that's picked it up over pretty much the whole length. So, very happy. So I've got the adapter I'm making set up in the milling machine, because I want to cut the make the cutouts for the drive dogs to engage on. And order of work here is a bit curious. I left this at full diameter at full length, rather than bringing it back to the flange sort of feature that I need, because I wanted to make it easy to do these slots. So when I do the first one, if I had reduced this to pass it right through, when I turned it over it wouldn't have sat correctly on the bottom of the vise. So by leaving the full length on here I can just turn it over. For the indexing, I've got an ER40 collet clamped on here with a square collet block, and it's on a, I don't know how well you can see, I should be able to see that well enough. It's just an adjustable parallel, which makes it easy to index the bottom face of this thing. So when I've done the first one, it's be flip it over and off we go. So I want this flange to be 6mm, the least that it needs to be, because obviously I'm still trying to keep this distance here minimal. So this is a 16mm cutter, and I'll come in to get the centre line of this cutter 6mm past that face. So then that should work out alright. And the depth of the cut, I measured the clearance between the inside faces of the drive dogs here, and it's just over 50 and a bit. So for my purposes, this diameter here is 63. If I come down 6.5, I should be good to go, and have just enough clearance there. So that's the game plan. Let's get on with it. Well, that cut beautifully, very happy with that. Right, so with my cutouts for the drive dogs done, I could mount the adapter and the spindle for the first time and do the draw bolt up. So it's my first opportunity to see what sort of a run out I'm going to get. The surface finish here isn't fantastic, so that might contribute a little bit. But it's my first go, who knows, let's see what we get. Well, that looks like 0.01, and some of that is the surface finish, but let's say the run out's 0.01. Half a thou, not perfect by any means, but I'm probably happy with that. It's good enough at least that I'll continue to do the ER40 side of the deal. So, some progress review. I milled a couple of flats on the socket, and drilled and tapped for a couple of 8mm socketed screws to use as drive dogs. This material wasn't large enough in diameter to put the correct inserted dogs on, but this will do the job just fine. And so I've got the milled cutouts for the drive dogs on the adapter, and a draw bolt. Let's do that up tight, and then it's back to the 4-jaw to finish this out. So I've got to bore it, put the taper for the ER40 collet, and then put a 1.5mm pitch thread on there. So I think the end is in sight. So I want to reset this in the 4-jaw, concentric on the taper as best I can, but the surface finish on that taper is making that very difficult, and my optimism for the accuracy here is diminishing rapidly. But I've gone to each of the 4 jaws and basically got the best average of around 0 that I can get. And after playing with it for a while, I don't think I can get any better. So it's going to be a bit of a crapshoot what comes out of this, I think. So there's a few lessons, no doubt, but anyway, I'm going to give it a go at that. Right, so the next challenge is to get the draw bolt into the back of that. Might move the tailstock up behind that to make sure it doesn't. Right, that'll hold that in place, because now I've got to come around from the other end of the lathe spindle and push a bolt in and try and thread it into the back of that. So this contraption is how I'm going to try to do that. Feed that in from the back end here, and hopefully find the end of the adapter. Or wishful thinking here perhaps. Oh, I just got lucky. Yeah, I think I'm in business. Right, we'll keep going here. Let's turn in the chuck now, that's promising. Just reposition the adapter so that it's properly engaged with the drive dogs, not just hanging around in no man's land. Alright, let's do this bolt up again. That should be tight enough. Alright. So now I think we're as good to go as we're going to get. So yes, I wanted to just reposition that so that the drive dog was on the correct face there. Okay, let's get set up for some drilling, boring and tapping. So obviously we'll start by facing this off. and turn it down to take an M50 by 1.5 pitch thread for the ER collet nuts. Okay, so I've got to cut an external thread here now. The nominal size is M50 with 1.5 pitch, so I've turned the blank to 49.9, done the scratch pass, which I think you'll probably be able to see, and now it's time to start cutting. Now, fortunately, because the my lead screw pitch is 6mm, I don't have to worry about using the thread chasing dial. I can just start and stop anywhere, and it will, because 1.5, the thread pitch of 1.5 is an integral factor of the lead screw pitch. It'll just sort itself out. Yeah, it's got a lovely feel to it. Right, time to bung a hole in here and do a taper. Okay, so now get set up for doing the taper. Okay, so we've got the lathe compound sine bar set up again to get the top slide or compound set to 8 degrees for the ER40 collet taper. So I think that's pretty good. I've got to turn it so that it's 8 degrees out to 40mm diameter at the outer diameter. Must be pretty close now, I think. Surface finish isn't too bad. Well, that's sitting there with 5 sticking out, which is yeah, about 5, maybe slightly more. Well, whether it's concentric or not is another matter, but it looks like it's going to work. And it looks also as if I could shorten it up a little bit too. There's more thread there than we need, I think. But that might be different. Now this collet is ranged from 6 to 5. That was a 6mm drill. I put a 5 in. So obviously the nut will now wind on quite a bit further. Yeah, so that's why we need the extra length. I'm pleased with the fit of the nut on the thread though, that's pretty good. Okay, so I finished making this thing, and at least it looks the part, and apparently works. So I guess the next thing is to put it in the milling machine and give it a test and see if it's any good. Okay, time for a report card on this adapter that I've made. I've got a 1-inch diameter tool bit in here, and let's see what the runout is. Yeah, I guess that's 0.07. Yeah, I wasn't expecting it to be fantastic, but that's probably worse than I was expecting. Well, that wasn't the outcome I was hoping for. But it was an interesting project, and I did achieve some of the things I was hoping for. I did actually make one which was shorter than anything I could buy. The threading worked out pretty well. The surface finish on the taper here is pretty good. So definitely some good things. I also made a bit of extra tooling, of course. Got my fixed steady T-nut sorted, and this socket, NT40 socket, might yet turn into be a useful tool. So what I'd really like though is from viewers feedback on the way I went about this, how you might have done it, if you spotted any deliberate mistakes, any suggestions that you have which would help me understand how to do this better would be really appreciated. But for now, I'm going to go back into the bunker with the dial gauges and try to understand exactly where this 3000's crept in. Hopefully it will be possible, for example, to validate this or maybe tune it up a little bit. And I've got plenty of the material now, so I'm happy to have a go at making another one. Anyway, if you stuck with me this far, thank you very much for watching. Hope you enjoyed it, and please consider giving me some feedback if you've got any suggestions on how I could do it better. But in any case, thanks for watching, and I hope to see you on the next one. Cheers.